Welcome back, students. We are doing question 3. So before we read, we look and study the diagram, the figure, the 2D shape. Okay, so it's a 2D shape. Let's read the question, because there's loads of information here. We see A, B, C, D. We see we have dimensions 8, 10, 14. We see the right angles. And I recognize it, D. Okay, it's from here. It's not a parallelogram because these two sides are not parallel. The top and the bottom are parallel, which makes it a trapezium. Okay, so it's a trapezium where this side is straight up and down, and this side is slanty. So it's not a rectangle. It doesn't have 4 right angles. It's not a parallelogram, because it doesn't have these two sides the same length. It's not a rhombus, because it's not a parallelogram with all sides the same length. It's a trapezium. Okay, now I've got my page 8 open and I'm looking at the trapezium, and I've got this question to work out the area. Now there's a formula here for the area. I could also, especially to this partition, do this rectangle and this triangle. But this is more powerful and this keeps it as one place, so we're going to go with this. We might look at the other one as well towards the end. Okay, so what is A? A is 14. Well, write down the formula. The area of a trapezium is equal to A plus B over 2. By the way, that's sometimes called the mid-section, because it's the average of those two, because you see it's halfway between them because of this line. So that's the midsection. A section is a line section. A line. I think line, mid-segment. Length. Line segment. Yeah. And so it's that mid-segment length multiplied by the height. Okay. Let's fill in the numbers into this. We have 14 and 10 over 2 times 8. Now we need to use times in our calculator. We'll take our calculator and we will go, well, I could probably find a quicker way, but I'm going to go like this with my fraction bar and fill it in exactly the way it is there. 14, whoops, daisy, del 14 plus, trying to hold the calculator so you can see it with the light and everything perfectly. So how am I doing? Oh, I shouldn't have closed that bracket yet. I should have gone down to the 2 and come out from the fraction, out from the fraction. Now I close my bracket. And as we learned this week, we have to do multiply by here. Multiply by 8. And I'm very grateful you know who you are, the student who pointed that out and got stuck with it. That's brilliant. Okay, so we've everything in there and the answer is 96. Equals 96, but we need to put our units in centimeters squared. Now while we're at it, we could have done 8 tens is 80. But when I'm working, a square bracket tells me its area. And over here, 14 take away 10 would have been 4. And of course 8 comes straight across because these are perpendicular, and this is a rectangle. So half the base by the perpendicular height, or 4, and that comes from the previous page again probably, or no it doesn't. That comes from a good bit on actually. I'm going to keep turning pages now to show you the one with the triangle. Have I gone too far? Have I not copied it? Obviously I haven't. I'm getting annoyed at myself. There it is. Half the base by the perpendicular height. The next, the previous page. No, the next page. And I missed it. Okay, so you're learning. I made a mistake, sort of, by missing it. I'm not stopping the video, am I? No way. Okay, so it's half the base by the perpendicular height. Half the base is 2. 2 eighths is 16. So that would have been another way to do it, another variation. And you'd have still got 96. There's no need for me to write it again. Okay, now we're asked to work out, and let's say we forgot what this means. Well, that's from geometry. So, and I'm really showing you how you can kind of never forget over time because the log tables are so great. So in our geometry, it's page 17, we'll be reminded of the meaning of all the notation. I'm going to write that word down, it's really important. Notation. So notation, especially geometry notation. So here's notation. You see the word. We should be copying these out. And what we have here is a translation for this. So this says distance from A to B. So when I write this one, I can pronounce it distance from A to D. If you're not pronouncing it like that, you're not talking maths in your brain. And if you're not talking maths in your brain, you're going to find maths harder. So say it, distance from A to B. And look at all the other ones, but not now, we're in the middle of an exam. Come on, cop yourself off. We have to keep going. So from A to D. And I have my helping triangle already written in because I was doing the area the long way. So that's good because now I've got my helping triangle and I don't have to use, well, I wouldn't be able anyway because there aren't coordinates, so I don't have to use the formula for coordinates because this is geometry. Okay, so we have our helping triangle, so we can go to Pythagoras now, which will be in trigonometry. I know it's on page 16 myself. That's 17, so we just go back one page, which is nice, by the way, because we're in this roughly the same space. Okay, and here's my Pythagoras in a right angle triangle. So A and B for us is 8 and 4. Okay, now I have it over here, but just for fun, I'll just model out freehand. My triangle is 8 and 4, and this is distance A to D. Okay. So I can call it distance A to D as if it was just a variable and say squared, it's worth 8 squared plus 4 squared. Okay, I could also copy this down, right angle A, B, C, and that's C squared equals A, let's do it exactly, C squared equals A squared plus B squared. So what it actually means is the area of a big square there is equal to the area of these two smaller squares, C squared, okay? And then what we can do is do so I've been talking to you today over a time over an inverse operation, multiply these two are inverse operations, these two are inverse operation, and here they are, the inverse operation squaring, which we don't want, we want to inverse it. So we do square root. So to inverse it, it goes away, the square goes away, and we use square root. You can push the button now too to start using it. 4 squared plus 8 squared. So I push the button, it's right next to my square, and I do 4 squared plus, always a plus, 8 squared. In there, always a plus. Okay, and the answer is 4 root 5. And then we look up and delighted, they want the exact form. They don't want to see that decimal approximation. They said it, give your answer in A root B, where A and B are natural numbers. Yes, 4 is a natural number and 5 is a natural number. Use trigonometry to work out angle DAB. I'm going to need this in a second, but first let's look here. There's angle DAB. Again, it makes sense to do our own little drawing here, but A is here, so I'm just going to call it A. I'm going to put 8 here, and I'm going to put 4 here, and I'm going to emphasize that it's a right angle. Now we're doing this we haven't done this in school, but we did it very quickly. As a quick introduction. So what we're doing is we're using either sine, cos, or tan. And what I'm just saying to you is, look at where these two meet. They meet at the right angle. And which of these meet at the right angle? It's A and B meet at the right angle. So we're using tan. So the tan of A, and you might remember, it's a really good idea to leave some space here, a nice bit of space here for a 3-letter word. Okay, and we're going to put in our numbers 8 over 4. Okay, now let's go back to our calculator to see how to inverse operation. Well, there's tan. Okay, there's your tan, and not beside it now, but behind it, it's the inverse operation, tan to the minus 1. So because basically this tells us what a fraction is for the angle, but we want the angle. So we need to do, the inverse operation is we're going to inverse tan both sides. But what that does to this is it makes it A. So this turns into A, and it's as if the tan comes over here, but just like I transpose or I divide down, there's some sort of a change always, and this change is this. Okay, well the angle A will be equal to, now we know this is 2, so we know it's going to be bigger than 45 degrees because we know, you know, like one of these ones like 60 degrees, because long here and short here, as opposed to, just a minute now and I hope I don't knock off the video, as opposed to this 45 degree where these are both the same length coming across here. So we know this is longer, so we know we're getting bigger than 45 degrees. Will we have a quick look at it? We will. Okay, so you just do shift tan fraction bar 8 over 4. We just happen to know where you get away with it without closing the bracket, just to save a bit of time. That does not look good. It's in radians. I borrowed this calculator from somebody in university, and they're working in a thing called radians. Yuck. Shift menu. You'll never probably have to do this, but if you ever see that R and you want to turn it into a D, you have to do what I'm doing now. You have to go into angle unit and turn it back into degree. Okay, and now I can do my shift tan again, or I can just look at my answer and it won't be right. Okay, I thought it might automatically change it, so I'll have to do shift tan. You might never see that again in junior cert, but if that there is not a D, or you do need to change it. Shift tan 8. So what happened there is I said I'm going to get an angle bigger than 45 degrees. I got a tiny angle, and I questioned it and said that can't be right. So it's great to have a prediction of what type of number you're going to get. You've just seen how it worked so well. So 63.434 is my truncated 63.434 ... 3 numbers, 3 dots is always a good way to go, and then we'll look at the degree of accuracy. So at the end you always look for degree of accuracy and you see what units they want and so on. Okay, the degree of accuracy is just 1 decimal place, so we'll go 63.4 because it's not going up, and we put an arrow there if it's going up, and that's it, 3.4 degrees. Okay, that's that one done. Let's grade ourselves. And by grading ourselves, when you're looking at your paper and if you feel disappointed, I'm showing you the marking system here, and there's no reason why I can't share it with you later too. But so let's get the overall gist of things. We're on question 3. First 2 lumped together is 10, then 5, and then the last 2 lumped together is 10. So the first 2 is marked out of 10. The next one is marked out of 5. Hold on. Let's look at that again. Oh yeah, and then the last one on its own is marked out of 10. Okay, this is difficult and it's given a good few marks. I suppose it should be. Right. Did we get trapezium? Yes. Did we get 96 centimeters squared? Yes. So they're both out of 10. We have 10 out of 10 there. Okay. So as long as we get it right, we don't really care about all the work. Did we get 4 root 5? Yes. 5 out of 5. Did we get 63.4 degrees? Yes. 10 out of 10. 10, 20, 25. Another thing that will be happening here now is I got 25 there. And question 2, I got 15 and 9, 24 out of 25. When we're doing the total, we'll have totted up and they'll have told us what the full marks are anyway, but we'll make sure it's correct. And here we got 15 out of 15. So far we're doing absolutely brilliant. Well, kind of. We dropped 1 mark. Tut tut. And next question is question 4. Sequences, patterns and sequences. They should be called sequence and series because you'll see that's what they're called in log tables. Okay. As always, I'll see you in the next one. By the way, let's look at the time. It took me 15 minutes, but I taught you an awful lot. I went a bit over, but I'm doing a lot of teaching. I think I could do it a bit quicker if I tried. Okay, see you in the next one.